So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss a topic called as Theoretical Framework for GIS. So in the previous lectures, we have discussed about different types of data like spatial data, non-spatial data, and we have just discussed about different types of data input methods. And even we have discussed about the operations, what are the fundamental operations, what you can do in GIS process. So that different operations we have learned in the previous session. Now today we are going to just learn how this all operation is done. What is the framework of GIS? What is the theoretical framework for GIS? What type of input is there? What type of data is used? And how the transformation transfers from the real world to the map system. So that we are going to learn today. So just let us start with the contents. So in our content we have theoretical framework for GIS, primary elements. So primary elements, we have spatial data, data models, spatial relationship, coordinate systems and projections, spatial analysis, cartography and visualization, database management, application and uses. So these all comes under the elements of theoretical framework for GIS. So let us start with this theoretical framework for GIS. What does it mean and how it works, right? So a theoretical framework for GIS GIS is Geographic Information System, typically involves a structured approach to understanding how GIS functions, its underlying principle, its application and its various contents. So how it functions, that means starting from the real world, we have a real world. Suppose this is our real world. So it is captured by the camera or sensor. After capturing by the camera, this data is converted to the raw data. Okay, raw data. Later, this raw data is converted to the final map. So this is the process of transformation. The theoretical framework means how it transforms to get the final map. So it has to go through the process, it has to go through the different functions or approaches to get the final map. Like real world is captured through the camera, captured through the satellite images, through the sensors. Later on the data is converted to the raw data. The raw data is converted to the final map. That final map is utilized for the GIS process. So these are the process how it goes on. So how data are transformed and held as a model of real world. So different types of transformations that data is subjected from conventional map making process. GIS example explaining the theoretical framework and transformation in GIS. This is what I was telling you about. Suppose this is the real world. Real world is the actual world. The actual world. So the actual world which is already present, the actual features what you can see on the earth surface, that comes under the real world. And that from the real world we call it as T1. So data collection, that is converted to raw data. So what is raw data here? Raw data is captured image or captured photo, you can say. So through aerial photograph or satellite image, that all comes under the raw data. So from as a basis of raw data, which is converted to the raster data, we can see this raw data is also known as the raster data. So this raster data is further converted to the map. So what is the map here? So map is our vector data. Okay, map is our vector data. So this is converted and the final output what we get is map image. The final output what we get is map image. So this is how the transformation stages in traditional cartographic process. First thing is capturing of the real world, then the raw data is converted. After the raw data, map is converted. After the map image is converted. This is how the process goes on in the theoretical framework for GIS. Now here in the same stages we can see here in a different image form. This is the real world called as T1. transformation 1, raw data, transformation 2, and data model. Later we can just transform into the data model T3 or T4 is the output, and the final output we can just get in the form of the map. Okay. This approach for transforming data into information is based on the cartographic principles. So cartography provides the understanding of relationship between the real world map as a model. So what is cartography? So cartography is related to the maps, right? So all the map, the cartographer will just prepare the map with the help of his, let us say, drawn to scale or with the help of the real world data. So cartography provides the understanding of relationship between real world and map. So what is the relationship between real world and map? This is the real world and this is the map. So map is, we can say, real world is 3D data. Okay, 3D. Map is 2D. So here we are having the 3-dimensional information on the real world. So 3-dimensional information is converted to the map. It's called as transformation. Like how we are transforming the 3D information to a 2D map to understand. So the cartographers will convert this real world features to the map model through the transformation techniques. So the real relationship helps in understanding various transformation in the real world data tasked to become a map. So theoretical framework is not related to any specific software. It is not related to any software, but it is a model. It is a model of how different processes take place in the digital GIS environment while producing the digital geographic spatial information. So process of analog map production may be modeled as a series of transformations between real world data, raw data, map and the final map. That means analog map production may be modeled as a series of transformation. Now the process is like, suppose you have a, from real world, you have a analog map, okay? Analog map. From analog map, you have transform the real world data to raw data. So this raw data is converted to the final map. So this is the whole process of transformation from the real world to the final map in the form of directly we capture the image. Either if you don't have that image, if you have an analog map, that analog map again it is transformed to the raw data. Again the raw data is transferred to the final map. So this is how again we have, you can see the transformation stages of traditional cartographic process: real world data collection, data input, data display. So real world raw data, map image. So in the first transformation T1. So when we are talking about T1 here, data are selected from the real world as for the example surveying measurements or the census data. So these are the input for the GIS in some from T2. Okay, so these are the input files in the T2. Then to provide the basis for its digital map representation of the real world. So within the system, a vast range of manipulations, operations are available to further transformation the data and store the results as T3. So T3 is the results out of it. So this may be communicated as a tabulated or a graphic images by means of hard copy or screen. So further output will be in the form of tabulated or the graphic data in the form of hard copy or screen. Okay. Now primary elements. So under this theoretical framework for GIS, there are few primary elements which will which are included in this, which are considered in this theoretical framework for GIS to run this theoretical framework. So these are the primary elements which will be contributing to theoretical framework for GIS, like spatial data. Spatial data, if you remember, we have discussed in previous lectures. 2-3 times we have already discussed about the spatial data. So what are spatial data? Spatial data are two types. One is vector data, the other one is raster data. So these two are spatial data. So spatial data, when you talk about vector data, it is in the form of point, line and polygons. Okay. And when you talk about the raster data, this point, line and polygon are represented as pixels. So each cell is having a value representing, each cell is having an information to the particular attribute or elevation or temperature. So spatial data we have two types. One is vector, one is raster. So vector data is like points, line and polygon. Points are used for discrete locations. Like what are the features which you can use in points are wells, lines for linear features, rivers, polygons, and for area we have lakes. Now same the way raster data represented by the grid cell of pixels. So each cell has a value representing a particular attribute. For example, for elevation and temperature. Next we have data models. So in GIS, like when we talk about the theoretical framework, so data models also contribute to the theoretical framework. If you want to make a data model, if you want to run this data model, you have to consider this framework starting from the real world to the final model process. So layer-based model organizes spatial data into layers, each representing a particular theme for feature, roads, and land use. Like in the previous sessions, I have discussed you about the layer-based overlay operations. Like overlay operations, what we have here is 1 layer, 2 layers, 3 layer, 4 layer. So different layers you have here for just assigning the information 1, 2, 3, 4, 5. So overlaying the different kinds of layers. So layer-based model is also like overlaying all the spatial data into layers, and each representing a particular theme or features like roads and land. So each layers will be maybe roads, land use. This can be land cover. Okay, this can be forest. Okay, this can be any other feature. Let us say something like spatial points. Spatial points. You can say some numbers. Okay. So here we can just create a layer-based model. An object-based model treats the geographic features as the objects with the properties and the behaviors. So layer-based model is like, this is one example you can see here, layer-based model. So as I told from real world, how it is converted to the different layers. So this is the real world. In this real world, this all information is available. Like topographic, you can say base, you have different kinds of zoning here. You have wetlands, land cover, soils, survey control, floodplains. So these all information you have already in this real world. So this information is taken from the real world. So this is the output. Okay, output. So from here you can just create different layers. Like you have a topographic base here, 1, 2, 3, 4, 5, 6, 7, 8. Total 8 layers are created from this real world feature. So this is the theoretical framework. How from real world you can just create the layers. Okay, layers in the GIS. So this is the final map. And what is the input here is? Input is real world. Okay. So converting the information from real world to the map image is called as theoretical framework for GIS. So transforming the real world information to the map information, okay, 3D information to the 2D information is called as theoretical framework for GIS. Now spatial relationship. When you talk about spatial relationship, topological relationships like relationship between spatial features such as adjacency, connectivity, containment. So this all comes under the topological relationship. Distance and proximity measures how far apart features or their nearness to each other, how they are adjacent to each other, how they are connected to each other, how they are far from each other, near, far. That all comes under the spatial relationship. For example, there is a road here, and along with that, adjacent to this, it has a railway track here. Okay, this is the railway track. Railway track. This is the road here, right? So railway track, road. So these two things are adjacent. Okay. So connectivity, if you want to see what is connectivity. So this is the road. If you want to connect this road, so one road is connected here, and this railway track also it is crossing. So connecting from one road to the other road. Now this road will extend, and there will be one more road like this. There will be one road like this. So connecting the roads to each other is called as connectivity. Connectivity adjacent to each other. Containments measures how far, how apart the features are, how near the features are, and how they are near to each other. That all information we can just check in the spatial relationship. when you're talking about theoretical framework for GIS. Now, if you're talking about theoretical framework, coordinate systems and projections. So this is also an important element in this theoretical framework for GIS. Coordinate system and projection means when you talk about real world. So real world is having all the coordinates, right? So this coordinates to be transformed to the map. So how can we transform this coordinate to the map? How the transformation can be done? So that can be done through the assigning the latitude and longitude. So real world is having the real coordinates. Okay, real coordinates. So this real coordinates to be assigned to the map. So how we can assign 3D to the 2D map? Through projections. Okay, through projections. So these projections we will be discussing in the coming lectures. So through projections we can convert this 3D information to the 2D information. So that kind of information, when you are converting this coordinate system to the map, that all comes under this converting the transformation of the 3D information to the 2D information. Okay. So the coordinate system uses latitude and longitude to specify locations on the Earth's surface. And projected coordinate system. What is projected coordinate system? Projected coordinate system transforms the Earth's curved surface to a flat map. So this is what I'm saying. Earth's curved surface to a flat map. This means what? This means 3D to 2D. So Earth is having a curved surface. Okay, Earth is having curved surface. Now converting this curved surface to the 2D. So converting to the flat surface is called as projecting the coordinate system. Now geographic coordinate system is assigning the latitude and the longitude. So actually Earth is having the latitude and the longitude actual coordinates. When you want to transform, then the transformation can only be done through the projections. So transformation means converting the real world to the map system is called as transformation, and that is what the theoretical framework for GIS is. Now when you talk about the spatial analysis, what is spatial analysis? Here we have overlay analysis, we have buffer analysis, we have spatial statistics. Buffer statistics. So what is overlay analysis? Overlay analysis we have discussed in the previous topics also. It combines multiple layers to find the relationship between different data sets. Okay. So combine multiple layers to find the relationship between different data sets means, as we have seen in this previous lecture, here. So what it is happening, these are the different layers. So what it happens, it will combine the coordinates. And attributes. Combine the coordinates and attributes to get a final layer out of it. Okay. So that comes under the overlay analysis, combines multiple layers to find the relationship between different data sets. So 1 layer, 2 layers, when it combines together, 3 layers, 4 layers, when it combines together, what happens? It will just find the relationship between different data sets. Now buffer analysis creates zones around features, analyze proximity and impact. So what is buffer analysis? Buffer analysis means suppose there is a point here. So when if it is required to create like 10 kilometers buffer around the points. So if I just keep a 10 kilometer buffer, what it will happen is it will just create a body out of this point. So that will be the 10 kilometer buffer. This will be the point, and the buffer will be created around this one. Okay. So this is called as buffer analysis. For example, there is a line feature. So if I convert this to a buffer, if I want to do any buffer here, so what will happen is I will just put the buffer of 5 kilometers, let us say 5 kilometers. So what will happen? It will create a line from both the sides of this line. So this will be 5 kilometers from both the center of the line. So buffering is like creating a zone around it. So for point, this is the zone. For line, this is the zone. Okay, for polygon, it will create another zone. This is the zone we can analysis if you want 10 kilometers buffer, if you want 5 kilometer buffer, 1 kilometer buffer, 500 meter buffer, that all we can create in GIS process. That means we are transforming the information to the final output of the map. So that all comes under the spatial analysis. When it happens, when the transformation can take place from real world to the 2D map. Now spatial statistics analyzes patterns, distributions of spatial data like hotspots analysis, cluster analysis. It is present in this statistics analysis. So it will analyze the patterns and the distribution can be allotted for the spatial data. Okay. Now cartography and visualization. What is cartography and visualization? Like map design, 3D visualization. So cartography is like related to the maps or related to the creation of the map. So the cartographers will be always creating their own map based on the map scale and all. And principles of creating clear, effective maps, including symbology, labeling, and the color theory. That all comes under map design. So map design, if you want to go through the map design, so creating clear, effective maps, effective map is created. This is the map, for example. So for that, symbology is created. What is symbology? Symbology here will be a legend box here, or here will be the legend box. So in this legend box, there will be a symbology, like there will be a symbol. For example, here, for example, this is red color, red, this is yellow. So this yellow color and red color, wherever you can see, suppose here is the red one. So wherever you see represents what? Red means you can write here settlements. Yellow means you can write here vegetation. So it represents, it's a legend box which will give you a symbol. Based on the symbol, you can just, based on the color, you can just identify in the map what kind of feature it is here. Okay. And labeling the feature, like if you have road here, so you have labeled the feature as it is NH highway, or it is state highway, or it is national road, or something like a local road. That all labeling we can do in this cartography and visualization. Conversion of the real world, this is what we are doing here. Like in a map, we are transforming the real world information to a map. Like actually on the ground it is available, but if you want to show in the map, what we are doing, from real world we are transforming the image to the map. Okay, transforming the image to the map. Now 3D visualization, techniques for visualizing data in the 3 dimension like digital elevation models can be created based on the 3D. Okay, now database management. Now spatial databases, specialized database designed to store and query the spatial data. Example like SQL, PostGIS, Oracle, and Spatial, that all database can be managed by the framework of GIS, data integrity and the quality, ensuring the accuracy, consistency, reliability, and spatial data can also be done through this theoretical framework of GIS. Now application and use cases. So environmental management, urban planning, disaster management. So few of these applications can be done based on this theoretical framework. So if you want to just apply this theoretical framework on environmental management, if you want to do the monitoring. So monitoring process can only be done when the real world data is transformed to the map. So on the map, this map can be used in GIS, and in GIS, the monitoring process can be done. Okay. So monitoring, managing natural resources, environmental impact assessments, that all can be done in this theoretical framework of GIS, because once if you want to show the real world information, that can be shown only in the form of map. And that can be only possible directly. We cannot show. First of all, the real world should be converted to a map system. The map, and the map is like, you can say before that we have raw data. This raw data then later converted to map, then the final output you can create. When you're talking about this environmental management, so monitoring, managing natural resources, environmental impact assessments also, if you want to do, that real world data should be captured in the form of 2D. So 3D to 2D, once it is converted, then the assessment can be done, because we cannot go to each and every place. But if you have that whole information from 3D to 2D, that means it is in a paper format or an image format or map format, that all can be directly monitored through this kind of data. Now you have urban planning. What is urban planning? Urban planning is designing, managing the urban spaces, infrastructure development. So when you talk about the urban planning is what? While planning the urban areas like to be managed, or different infrastructure developmental activities can be done in this urban planning. So what type of infrastructure, like road networks, railway networks, if you want to go with the construction of the buildings or different kind of residential areas, commercial areas, industrial areas, that all planning can be done through this theoretical framework when the data is converted from real world to the map. So how it is converted? This is only the process. Real world, that raw data, then map, and the final output in the form of an image. Okay, so urban planning, designing, management, and managing of the data can be done. Next is disaster management. So disaster management is also one of the important, you can say, element here. So disaster management, if you want to just find out the risk assessment. What is risk assessment? Risk means finding the risk places, which places are on the risky areas, which places are on the vulnerable areas. That all areas, if you want to just find out, you have to just convert this real world information to a image format or the map format. Then only you can just go with this process. Okay. Emergency response planning, if you want to do, then if you have this satellite data, you can say satellite data to a image data. So image data can be viewed in the GIS, and then that 3D information which is converted to the satellite 2D information, and then further image data. Then we can just go with this emergency planning, which are the places where the emergency planning or response can be initiated or immediately recovered or activated. Whichever the accidents will happen, wherever the accident occurs, so immediately response can be given to such areas. So that can happen due to this theoretical framework for GIS. So this is what we are going to do whenever we work with GIS. So first of all, you understand how the data is converted to the image format, how we are able to use in GIS. Previous lectures we have just studied about spatial, non-spatial data input, how the data came, how the data is available, how the data we are able to work out. So that all comes under this theoretical framework of GIS. Okay. So once the data is converted to image format, once the data is converted to 2D to 3D map with the proper projection systems, and then later we can just use that data for the different kinds of process applications or different type of disaster management or environmental management or something like urban planning systems at all. You can just use with this kind of information. So I hope you understood about the theoretical framework for GIS. So what is the theoretical framework? Just remember, it is conversion of real world to image or map. So in one word, if you want to say, just say 3D to 2D. So you are converting the 3D information to 2D. So real world is 3D, 2D is the map. 2D is the mapping. So that all information you can just get to know with the help of this theoretical framework for GIS. Okay. So these are the references you can just go through to find out the more information about the theoretical framework of GIS. You can just go through this MNG Ready book, and you can go through the links to find out the more information, and you can go through this book for the getting the more GIS information from PMH publications and corporations of Tangchang GIS. Okay, so Tangchang is the book for especially for the GIS only. If you want to do find out the more information about the GIS, you can just refer this book, or else remote sensing in GIS also. These two books are very good for remote sensing in GIS. Okay, so you can just go through to find out the more content. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.